The ideas in this video are quite tricky, but really interesting. We're going to look at how we can generate a current from just using a magnet and a wire. And it uses this process called induction. Then we're going to look at how a generator works. And then lastly, we're going to look at how we can generate more current from that generator. Before we start, I need to explain how magnets work. A magnet has a magnetic field which completely surrounds the magnet. In a very similar way to the Earth has a gravitational field which surrounds it, and anything that moves in that gravitational field will get pulled towards the Earth. A magnet works by having these field lines that surround the magnet. And if a magnetic material goes into those field lines, it will feel the force from the magnet. Now we can't see them, but they're invisible. But if we shook a load of iron filings onto a magnet, they would fall into those field lines and we'd be able to see it clearly. This picture shows exactly that. Now this is just iron filings surrounding a magnet. And those iron filings form on the same line as these field lines. So here's a cartoon just so we can see it a bit clearer. Now you can see these field lines that surround the magnet and those iron filings aligned into those field lines so we could see it. Now there's two things you need to know about a magnet. The magnetic field lines are always drawn north to south. So if you have over here, the arrow always goes away from the north and then it goes towards the south, always. And therefore in the middle you can see these sort of semicircles and their arrows must go always north to south. The other thing we need to know about magnets is the closer the field lines, the stronger the magnetic field. Take a look at the circle on the left. That has quite a lot of field lines in it, and the circle on the right just has one field line in it. That means the circle on the left has a much stronger magnetic field. And that's what we'd expect because that's the pole of the magnet. The end of the magnets are called the poles, and that's where you'd find the strongest magnetic field. Okay, now we can move on to the idea of electromagnetic induction. I'll start with a quick word explanation and then I'll show you a picture to try and explain it. Now, this is the first part. When a current flows in a wire, it will generate a magnetic field around the wire. Now, lots of people ask me, why does it do that? And this just does. It's something that happens. When an electron flows, it creates this magnetic field. Now it's kind of a weird idea, but you just need to accept it because it's a bit of a strange thing, but it just does. Now the same thing of this, but backwards, if you like, is this statement here. When you move a magnet near a wire, the electrons will feel a force, and this will induce a voltage. Now this is the same statement, but backwards in a way. So if you move a current, it will make a magnetic field. And if you move a magnet, it will make a current. It's the same thing. So it's quite important, so I'm going to put a big box around it, and we can use that for the future. Most things in these next few sections all come from this one rule. So if you want to pause it, go back and then have a look, or have a look at these next diagrams and really understand it before you move on, because they all come from these two rules. Here's a diagram to explain that first statement on the last slide. When a current flows in a wire, a magnetic field is induced around the wire. Induced means to make. So when we've got this blue wire here, and a current flows along it, we get these rings that go round the outside of the wire, and they go all the way up the wire. And that is the magnetic field. The red rings here are the magnetic field. Now the right-hand rule is a rule that we use to work out the direction of this field. What you do is you take your right hand and you point your thumb in the direction of the current. So here it's pointing upwards. Then you grasp your fingers around the wire and your fingers point in the direction of that magnetic field. And that's the way we use to work out what direction. If I turned my hand upside down, so my thumb is pointing downwards, you can see that your fingers are now pointing the opposite way round the wire. And that's how we get the arrows on the end of these red lines here. Now this is the second statement on that previous slide. When you move a magnet near a wire, the electrons will feel a force and will move. And as soon as the electrons move, that is your current. What we say is that it induces a voltage. It's a really, really important word, induces. It means to make a voltage. And that voltage will cause the current to flow. Now, this rule is really, really important, these two rules. Now, you should go back and watch the video again if you didn't quite get it. But it's saying, if an electron moves, it will make a magnetic field. And if you move a magnet near an electron, it will make the electron move. And that is your current. So it's sort of the same statement, but backwards. If the current moves, it will make a magnetic field. And if the magnetic field moves, it will make a current. There are lots of topics that use the idea of electromagnetic induction. So it's really important you get this idea before we move on. We're now going to look at a generator. This is a very simple generator. Now it's made of a coil of wire at the top and an ammeter at the bottom. Now if I placed a magnet over here, you can see that there's no current detected on the ammeter. If I placed the magnet inside the coil, there's still no current. And if I placed it over here, there is still no current. If you place a magnet near it, it won't make a current. What's really, really important is that the magnet moves in a coil of wire. So the magnet has to move, and as you can see at the bottom, the ammeter is now detecting a voltage as long as the magnet is moving. So the technical words you have to remember is moving a magnet in a coil with induce a voltage. It's this word induce is the most important here. And that means you will create a voltage, and that voltage will make those electrons move. And that's your current. The second thing you needed to know about a generator is that moving a magnet in the other direction will mean the current will flow in the other direction. As you can see from the ammeter at the bottom, moving this magnet to the left makes this ammeter point into the other direction, to the negative direction. Now that doesn't mean it's got a negative current. The current will just be as big, but it just means it will be flowing in the other direction. So positive and negative current on this ammeter will be exactly the same size, but the current will just be flowing in a different direction. Moving the magnet in and out of the coil of wire on the last slide will produce an alternating current. This is the graph that would have been produced if we had moved the magnet in and out just once. On the y-axis you can see a current, and then on the x-axis you can see time. Now this first half of the graph is when you move the magnet into the coil, and the second half of the graph is produced by moving the magnet out of the coil. Now the bit in between those two, where the current is 0, is produced when the magnet has stopped just for a second when it's changing direction. This is the last part of the video where we're going to look at how to induce a larger voltage in this generator. So you have in this generator a coil of wire, an ammeter and a magnet. I want you to pause the video and think of some ways in which you can induce a larger voltage. Here are 3 ways in which you can induce a larger voltage. The first thing you could do is use a stronger magnet. This would mean that the electrons would feel a larger force and therefore more voltage is induced. The second thing you could do is increase the number of turns in the coil. That means more electrons would feel the force of that magnet. And the last thing you could do is move the magnet faster. Now, these three ways you must know about how to induce a larger voltage in your generator.